This is an A-level mechanics question on projectiles. A boy throws a ball at a target. At the instant when the ball leaves the boy's hand at the point A, the ball is 2 meters above horizontal ground and is moving with speed u at an angle alpha above the horizontal. In subsequent motion, the highest point reached by the ball is 3 meters above the ground. The target is modeled as being at the point T as shown in figure 4. The ball is modeled as a particle moving freely under gravity. Using the model in part A, we need to show that u squared is equal to 2g over sine squared alpha. So with any projectile question, in the vertical, we will use suvat because we have a constant acceleration, which is gravity, g, so we'll put that on the diagram. And then horizontally, because we have no acceleration, actually the projectile's moving at a constant speed. Horizontally, we'll use speed, distance and time. So I'll just put that in. Speed equals distance over time, and that will be for the horizontal. I'll now put on the horizontal and vertical components of the initial velocity. So horizontally, that'll be u cos alpha, and vertically, that will be u sine alpha. Now I'm not going to derive this equation here by using speed, distance and time because there simply isn't enough information. All I know is the initial velocity or speed, horizontally is u cos alpha. That's all I know. Whereas with suvat, if I take this highest point here where I know v is equal to 0, I've got enough information to start writing an equation out. So let's write down suvat. I'm taking upwards as positive. It normally makes sense to take the initial direction of motion as positive. S, now we're considering this point here. So at this point, the displacement from the initial position is going to be 1 meter. So S is 1. U, well, we've got that on a diagram. That's u sine alpha. V, at this highest point, it's 0. And A is going to be negative 9.8, but I'm using negative g because if I look here, I've got my working in terms of g, so we'll just write negative g. So an equation that we can use for S, U, V and A, that's going to be v squared is equal to u squared plus 2as. So we can substitute that in. V squared will be 0 squared, u squared will basically be u sine alpha all squared. And then we add 2 times by g, or a, sorry, which is negative g, times by s, which is 1. So then we have 0 squared is equal to u squared sine squared alpha minus 2g. We can rearrange it to get u squared sine squared alpha is equal to 2g, and then finally u squared is equal to 2g over sine squared alpha as required. The point T is at a horizontal distance of 20 meters from A and is at a height of 0.75 meters above the ground. The ball reaches T without hitting the ground. Part B, find the size of angle alpha. Okay, so let's put that extra information onto our diagram. So we have a distance of 20 meters horizontally to get to T, and then we have a vertical distance above the ground for this point T as 0.75 meters. So we now know the horizontal and vertical distance to point T, which means it horizontally and vertically is going to take the same amount of time to get to here, so we can use the horizontal and vertical components of the projectile motion and use that to find the value of alpha. So let's start horizontally, where we use speed, distance and time, and the time is going to be equal to the horizontal distance to that point, which is 20, over the speed horizontally, which is going to be u cos alpha. So we've got t is equal to 20 over u cos alpha. Now also from part A, I'll just put this down because this might be useful as well. We've got u squared is equal to 2g over sine squared alpha. So I'll just put that there just in case we need it. Now we'll do SU that vertically, taking upwards as positive. So S, U, V, A and T. So now let's look at the vertical displacement. Since we're taking upwards as positive, and it's now at a point which is below where we initially projected this particle, is going to be a negative, and it's actually 1.25 meters below the point of projection. So it's going to be negative 1.25 for S. U is going to be U sine alpha. That's positive because that's going up. V we don't know and we don't really care about. A, well, our gravity is going down, so that's going to be negative G, opposite to my positive direction. And then for T, I can take what I have here. I can just substitute it in because it's the same point. So that's 20 over U cos alpha. And I want an equation to use SU, A and T in, and that's going to be S is equal to UT plus half AT squared. Right, so let's get everything substituted in. So we have negative 1.25 is equal to U, so that is U sine alpha, times by T, well that's 20 over U cos alpha, plus half A, that's negative G, T squared, so that will be 20 over U cos alpha all squared. Right, let's see what we can do to tidy this up. So negative 1.25. Now here we'll end up with U sine alpha over U cos alpha. The U's will cancel out, leaving sine over cos, which is tan. So we'll have 20 tan alpha. If we move to this bit over here, then we'll have negative G over 2. Let's actually put in the value of G, 9.8. So we'll end up with negative 4.9. And then in the brackets, 20 squared, so 400 over U squared cos squared alpha. Now I'm going to bring everything to one side because it looks like I might be getting a quadratic. And at the same time, if I have a look at this, I've got U squared. Now, what did we work out in part A? That U squared is 2G over sine squared alpha. So I'm going to substitute the U squared here for this 2G over sine squared alpha. So bringing the whole of this term across, I'll basically get 4.9 and then 400 over U squared becomes 2G over sine squared alpha, and that is going to get times by the cos squared alpha. So that term has come across. I'm also going to bring this across, so minus 20 tan alpha, and then minus 1.25 is equal to 0. Okay, let's see what we can do from here. I'm going to deal with the numbers. So I'm going to deal with the 4.9, the 400 and the 2G. If I work that out, that actually just becomes 100. Then what that leaves me in the bracket is 1 over cos squared alpha over sine squared alpha at the bottom. So you may know what's going to happen next. And then minus 20 tan alpha minus 1.25 is equal to 0. So this here, this is basically 1 over cot squared. So this becomes tan squared. So I end up with this quadratic 100 tan squared alpha minus 20 tan alpha minus 1.25 is equal to 0. So let's solve this for tan alpha first of all. So I'll get tan alpha is equal to a quarter, and then the other value I'll get for tan alpha is negative 1 over 20. Now if I do the tan inverse of negative 1 over 20, I get a negative angle. It's like negative 2.8624, so we can forget about that. But the other one does give us a value of alpha is equal to 14.0362 and so on. So I'll give that to 3 significant figures, or you could do 1 or 2 decimal places, totally up to you. So 14.0 degrees cubed degrees, and that is to 3 significant figures. Part C, state one limitation of the model that could affect your answer to part B. Now always look back at the original question and see if anything's been ignored. Now in this question it doesn't say anything about ignoring air resistance or anything like that. So we could mention air resistance. That will make a difference. We could talk about the spin of the ball. So any one of these, it's only 1 mark I think of this part of the question, spin of the ball. We could talk about the dimensions or the size of the ball as well. So dimension, size of ball. Or we could also mention something about the effects of wind. So any one of these will be fine as something that would affect our answer. Now something that would not affect our answer is the mass of the ball. The mass of the ball, or mass, does not occur in our working at all. So mass is not going to make any difference to our final answer. And lastly, part D, find the time taken for the ball to travel from A to T. Okay. Now I think the easiest way to do this is to use the horizontal, because we're just dealing with speed, distance and time. So I can say that the time taken is going to be equal to the distance. So I'm looking at horizontal here, which is 20, over the horizontal speed, which is u cos alpha. Now I have alpha, but what I don't yet have is u, so I'm going to use this here to work out what u is. So u will be equal to the square root of 2g over sine squared alpha. I'm going to use my answer button to get the most accurate value for alpha I can, and that gives me 18.2537 and so on. So I'll get all the values that I need. So t is 20 over u, so again I'll be using the answer button, 18.253 number, times by the cosine of my angle, so that's 14.0362 number, and then stick that all in on a calculator and see what we get for t. And I've got 1.12938. Let's give that to 3 significant figures. So I'll give t as 1.13 seconds, 3 significant figures.